This is SOL A.9. The student, given a set of data, will interpret variation in real-world contexts and calculate and interpret mean absolute deviation, standard deviation, and z-scores. Okay, this table shows data on the number of dollars raised during a fundraiser for 4 different classes and for 1 student in each class. Okay, so if you look at it, you have Jill, Kelly, Monroe, and Tim, and across you have the mean for their class, the standard deviation for their class, and the student's personal z-score. So the question says, which of the 4 students raised the greatest number of dollars? Okay, so when you see z-score and you're dealing with this question, remember you do have the formula given to you. Z equals x minus mu over sigma, where x is the individual element in the data set. So in other words, these students, their individual amount that they raised, mu being the mean for their class, sigma being the standard deviation for their class, and z being their z-score. So for this question, you're actually going to have to do backward z-score, solving for x for all 4 of them to see who actually sold the greatest number, the most amount. Okay, because remember their z-score is just telling us relative to their class how many standard deviations above the mean they were. Okay, so for Jill, we have z-score of 1.8. We're trying to find x. We know the mean is 60 and the standard deviation is 11. So then to solve for x, we're going to multiply by 11 on both sides. You get 19.8 equals x minus 60, and then to solve for x, add 60 to both sides. So the amount that she raised was $79.8, so $79.80. So we're going to have to do that for all 4 of them to see who sold the actual total that was the highest. Okay, for Kelly we have z-score of 2.1, trying to solve for x, mean of 58, standard deviation of 12. So again, multiply by 12, then add 50. So you get 25.2 equals x minus 58, and we get $83.20. So we know already that it's not Jill because Kelly is higher than Jill. Okay, now for Monroe we have z-score of 1.4, mean of 55, and standard deviation of 13. Again, multiply by 13 on both sides. We get 18.2 equals x minus 55. Okay, and he sold $73.20. So we know it's not Monroe because that's the lowest so far. Okay, and for Tim we have z-score of 2.5, mean of 57, and standard deviation of 10. Go ahead and multiply by 10 on both sides. We get 25 equals x minus 57. Add 57 to both sides, and we get $82 even. So the person that sold the greatest number of dollars was Kelly. So that's a long question, but totally doable. Remember, you are given this formula. You just have to make sure you know which part you're plugging into. Okay, the data set shown has a mean of 37, a standard deviation of 6.3, rounded to the nearest tenth. How many of these data points have a z-score greater than negative 0.6? Okay, so remember our formula. Z equals x minus mu over sigma. Alright, one approach to this problem would be to go through and find the z-score for every single element. That would take a long time. So I think the easier way to do it is to find a cutoff point. Because if you can find the element that would have a z-score of negative 0.6, you could kind of draw a line and then count how many are greater than that. Because remember, z-scores, if they're negative, that means they fall below the mean, and if they're positive, they fall above the mean. So since these data points are already in order for us, we can just find the cutoff point. So I'm going to plug in everything I know. Z-score of negative 0.6 equals x minus mean of 37 divided by standard deviation of 6.3. And now, just like the last problem, I'm trying to solve for x. So I'm going to multiply by 6.3. Okay, and we get negative 3.78 equals x minus 37, and then add 37 to both sides, and we get 33.22. So notice that would fall between 32 and 33. Technically, 32 is going to have a smaller z-score than 32.33. So you're going to draw it there, and that means that every data point greater than that has a z-score greater than that. Okay, so then we just have to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 data points. 1, 2, 3, 4, 5, 6. With a z-score greater than negative 0.6. Okay, very similar problem, only we're going to click on the numbers this time instead of counting how many. So, a set of data for the number of points a basketball team earned for each of 9 games in a tournament is shown. The mean for the data set is approximately 80.1, so again, there's my mu. The standard deviation is 6.1, there's my sigma. Using these approximations, which scores are within 1 standard deviation of the mean? Okay, so remember, within 1 means they might have a z-score of negative 1, or they might have a z-score of positive 1. So again, what I would do is set up 2 equations trying to find the cutoff point. Okay. And then for both sides, I'm just going to solve for x. So for within 1 standard deviation below the mean, we get a cutoff point of 74. And for 1 standard deviation above the mean, we get 86.2. So now you're looking for all the values that fall between those 2 numbers. Okay, you are writing your answer in the box, and it's telling you to round to the nearest hundredth. And again, so you're going to end up using a decimal point. A data set has a mean of 68.42, standard deviation of 7.91, and an element in this set is 57. What is the z-score for 57? So it's just straightforward z-score. You're plugging in everything else, which would be x is 57, remember x is the element, minus a mean of 68.42, divided by a standard deviation of 7.91. Now, before we even calculate the z-score, notice that the element is below the mean. So that means I should get a z-score that's negative, and if I don't, then I didn't do something right. Okay, so you end up with a z-score of negative 1.44. And when you have it on the calculator, it looks like negative 1.4437, round to the nearest hundredth. So you have to only type 2 decimal places to get that correct. Okay, last one. The mean for a data set is 45. The z-score for a data point A is 0, and the z-score for data point B is 0.2. Which are the possible values for data points A and B? Okay, so they don't give you an element, they just call it A and B, and they don't give you a standard deviation. So you actually can't do straightforward calculation for this one. Instead, you sort of just have to think about what you know about z-scores. So if the mean is 45, and the z-score for A is 0, remember, z-scores tell us how many standard deviations away from the mean something is. So what that means is that data point A is 0 standard deviations away from the mean. So if it's 0 away from it, A has to be the same as the mean. Okay, so it has to be C or D. We know A has to be exactly 45. Then it says the z-score for data point B is 0.2. Now we can't figure out exactly just from that information, but we do know that that's a positive z-score, so B has to be greater than 45. Okay, well, that would have to be C then. B is 45.8, not 44.2. And that's it for this one.